Okay, so we are going to discuss the transformation ratio. And then in our first video, we had a discussion on how to derive the EMF of an what? Of a transformer, right? And then we discussed that what? For a no load ideal transformer, V1 is equal to what? That of what? E1. And then V2 is equal to what? E2. Where V2 is the terminal output voltage. So let's look at the ratio of what? E2 to the what? To the E1, right? And we know the parameters of E2, where E2 is equal to 4.44, the frequency, the maximum flux multiplied by the number of turns. So this one will give us 4.144 frequency, maximum flux and the number of turns, all divided by what? E1, right? Which of course E1 is the what? 4.44 frequency, flux and the number of turns within the primary, which is also known as the self-induced EMF in the primary. So this will give us 4.144 maximum flux multiplied by what? N1. Which of course we know the flux is constant throughout, frequency is constant, and we have this constant parameter. So therefore we can say E2 on what? E1, right? Is equal to what? N2 on what? N1. And then is equal to what? V2 over what? V1, which is equal to K. And this K parameter is very important because it is what we term as what? The transformation ratio. And then the transformation ratio is very important because it helps us to know as to whether a particular transformer is a step down transformer or a step up transformer. We are saying that anytime the value of K is greater than 1, then the transformer is what? A step 1 up transformer. Okay. And then anytime K is less than 1, then we are saying that what is a what? A step down transformer. Okay. Now, let's look at the power within the system, right? We are saying that what transformer, the input power is the same as the output power. That means that what? That means that what? We have I1, V1 to be equal to what? I2, V2, which simply means that what? Within the transformer, the power within the system is constant throughout. It means that at a point where the voltage is what changing or increasing, the current what will decrease or increase in order to compensate for the power within the system. So power will remain constant within the system at any point in time. Okay. So let's take the ratio of what? V1 to that of the V2. So it means that our V1 divided by V2 will be equal to I2 over what? Over I. And realize that what? The I is changing from that of the V's, right? Which will be equal to what? E1 on what? E2. And that will also be equal to what? N1 all on what? N2. And this will give us what? The reciprocal of the transformation what? Ratio. Thank you very much, and then we are going to meet in our next class. Bye.